Hi, this is What's for Dinner, Day 1. We're going to take a look at our notes, and hopefully you'll feel comfortable if you missed class about what we went over. All right, so our guiding question for this whole section is, how do organisms in a community interact to obtain the matter and energy they need to carry out their life processes? So that's a big way of saying, how are organisms that live in a community interacting to basically eat and survive? All right, quick reminder, you are going to turn in your ecosystem packet October 30 or October 31, depending on whether you are in odd classes or even classes. So double check that you have all 9 organisms listed and classified, and they are also supposed to be drawn in your ecosystem picture and labeled. By the time you turn in your packet, you should have 8 days worth of data completed. Right now, you either have 6 or 7, depending on whether you've actually had this class. So we've done reflections in that packet just for day 1, 2, and 3. We did not do reflections for 4 or 5 or 6. We will probably not do another reflection until day 8, just so you know what you should have in your packet. All right, and also you want to attach your watershed walk notes. Those were the notes that we took about permeable and impermeable and stormwater drains and sewer systems as we walked around the Frost campus. All right, so starting this new section called What's for Dinner, what are you going to say to Uncle Joe when he comes to dinner and asks you what's happening at school? You're going to say, well, I am learning stuff in science. I'm learning about Yellowstone National Park so that I can see how it is a unique ecosystem influenced by human activity. Also, we're going to do water quality indicator checks in our ecosystems in the classroom. How are we doing all this? We're going to read. We're going to watch a video, or actually a video and a half. We'll think about different perspectives that people have about land use. And we're doing that all so that we can see how organisms in a community interact to obtain the matter and energy they need to carry out their life processes. So in class, I've passed out a packet called What's for Dinner. And you can print that out if you'd like to from the PDF file that's listed in Schoology, or you can swing by if you don't have a copy and pick one up. So we actually didn't do the first page first. We got into the middle of the packet and started defining this vocabulary. So I'm going to show you kind of in the textbook how we can get this information and the types of things I'm asking you to do here. So if you read the directions, it says for each term, use the textbook or the link to the textbook to find the definition. Then explain each term in your own words. Don't just Google it. I can tell the difference. Then, in the picture column, draw a brief example to help you remember the term. The first one, ecology, is done for you as an example. So really don't just Google the term, because if you Google it, you'll get likely a valid definition, but it may not be relevant to exactly how we're using it here in 7th grade science. All right, so I'm going to ask you to go into Schoology. So if you go into Schoology, you can go in for your own class period. This happens to be 7th period, but you should have a black folder that says Course Resources/Textbook. That's what we're going to use here. So Course Resources/Textbook. When you click on this link, of course, it's not quite as handy as we want it to be. It's going to act like the link is broken. It's not true. You can click the words again, and then you'll be over here in our textbook, basically. Okay, and so you can see we've got our chapters listed over here on the left. So our first term was ecology, and on your paper that you print out, it's just going to say section 14.1. It's not going to have the page number. But if I go to section 14.1, that means chapter 14.1. Let me see if I can get myself back to the textbook. 14.1. I'm over here in chapter 14. I'm clicking 14.1. And so these are the pages for 14.1. Okay, ecosystems support life. I need to expand that. And 14.1, I'm defining ecology. So in the textbook, usually at the beginning of each little section here, it's actually going to list the vocabulary words that they are trying to highlight. So you'd see this word ecology is on page 473. So if it didn't happen to be on the very first page, probably it's listed here. The word ecology is on this page though, and it's highlighted. Things are highlighted and bolded. So I see that it's highlighted in a paragraph that starts with living things depend on the environment. So I might read this whole paragraph because it's probably got cool, interesting information in it. You wouldn't find a kangaroo in the Arctic, and you won't see a polar bear in Australia. Each of these organisms is suited to a certain environment. The kangaroo and the polar bear are able to survive despite the harsh conditions of their surroundings. Ecology is the scientific study of how organisms interact with their environment and all the other organisms that live in the environment. So that section right there is my definition. Ecology is the scientific study of how organisms interact with their environment and all the other organisms that live in that environment. So if I go back to my page, you can see that our example for a definition is the study of how living things interact with each other and their surroundings. Now there is a picture. Oops, let me see if I can pull that picture back up too. There is a picture that actually came from the textbook. Can I find it? Only maybe. So there's a picture that has a horse and it has a little pond or something. I don't know if I can get back to page 472 because this is not really an interactive textbook. Let's see if I can go over here to 14. Nope, I don't think we actually have that picture. So look closely at the picture that's on your packet, and it's showing a horse that has, in its environment, in its ecosystem, it has some plants and the sun, because the sunlight is helping the plants do photosynthesis, has some water, so it's got some biotic and abiotic things. All right, so in class, I'm going to minimize that. In class, I asked people to work on, there are 18 different words. So we spent some time doing definitions, and then I had everybody pause. So 12 minutes was obviously not enough for 18 different words, but I had everybody pause so that we could do our water quality indicator testing. Forgive me, I have a cold today. So completing all of those definitions is homework if you don't finish it in class. I wanted to bring up a quick point. We just took a test on the watershed walk. If you look in SIS, you can see your test score. Right now, you can't see your test in Schoology until I have a couple more people make up the test in the first place. But if you got below 16, you're eligible for a retake. 16 out of 20 is 80%. If you got below 16, you are eligible for a retake. But if you got 15.5, that's close enough to 80%. You can only have a maximum of 80% in SIS. So usually if you got 15 or below, in this case, I wrote a note in SIS that says that a retake is recommended. So if you want to retake, then you're going to want to come to me or Mr. Bazan, if he is also in your class, to see which questions you missed since you can't get into Schoology just yet. And we can talk about other things that you can look at. Of course, always look at your exit tickets, and we had a lot of vocabulary that we gave as a sort of a study guide. So if you want to retake, this was written last week, so it's this week, maybe on Wednesday, but more likely on Friday we'll offer a retake. All right, so important, you want to make sure you get all 18 definitions taken care of before we have class. All right, then we wanted to go into our water quality indicator testing and put in the date. So today's jobs were temperature and clarity for A, dissolved oxygen for B, C was pH, and D was nitrite. And so everybody had time to do their water quality indicator testing and share data. If you weren't here in class, make sure that you get the data from your classmates. Okay, we had a moment to look, if you can pause the video if you want to do that, moment to look for doves among the cockatoos. Cockatoos always have these crazy head combs, but the doves do not. All right, so then I asked everybody to think of an area with lots of nature, such as a park or a field or a garden, even your model ecosystem. And back to our packets that we got for today, in the very beginning, these exact questions are listed on here. We've asked you these questions before, if you can think back to biodiversity. So fill in on your What's for Dinner packet what living things might be found in the chosen area, the area you're thinking about, and how might they interact. Just bullet points is fine. Remember, what we're thinking about in general is how do organisms in a community interact to obtain the matter and energy they need to carry out their life processes. So we had some people who listed like trout and damselfly and lily pad, and those are interacting because the trout is eating the damselfly, and the lily pad is producing oxygen that the trout is getting in the water. And so if you listed a couple of living things that you found in your chosen area, you could come up with ways that they interact. And a lot of times you'll be able to figure out what kind of an area somebody was thinking about if they tell you the plants and animals that live there. Okay, then on that same packet we have an introduction, which we did not need 6 whole minutes for, but I asked everybody to read that and annotate at least 2 annotations. That means highlight or underline or put a star by words that you don't know, or words that are used in a way that you're not used to, or something that you find interesting. So the introduction here, it says, in an ecosystem, living organisms interact with each other and with non-living things in their environment. Organisms interact in various ways. One type of organism may eat another or may be eaten. Organisms can compete for resources such as food, space, or water. Organisms can also interact in other ways that may be helpful to one or both types of organisms. In some case, what is helpful to one can actually harm the other. So I had tossed out an example. If you have a dog that has fleas, it's not really helpful for the dog. The dog's kind of itchy and uncomfortable, but the flea is very happy. The flea is being helped quite a lot. And so that's a case where one is being harmed and the other is not. If I have groundhogs that dig tunnels in the ground and then move on and go dig tunnels someplace else, if a fox usurps that tunnel and decides that it's going to be a nice place for a den, the groundhog is not harmed and the fox is not harmed, and the fox just happily has a place to live. So we have different ways that organisms can interact. All right. In this whole investigation for What's for Dinner, we're going to use the introduction of gray wolves to Yellowstone National Park as a case study to help differentiate between different types of interactions among organisms in an ecosystem. All right, so do you remember these pictures from biodiversity? Do you remember what this was called? This is called rewilding. Rewilding means to return an area to a wilder or more natural state. Often this means doing nothing and letting nature run wild. Forests, for example, can regrow on their own if we simply leave the land alone. Sometimes, however, we can also assist nature by bringing back plants or animals that used to live there. That's what we're going to think about. So rewilding is bringing back to a normal state. And again, we're focusing on Yellowstone National Park and introducing gray wolves back into that ecosystem. Think about whether you've ever been to Yellowstone National Park. These are images from the park. The Yellowstone National Park is a nearly 3,500 square mile wilderness recreation area atop a volcanic hotspot. It is located mostly in the state of Wyoming, with parts in Montana and Idaho too. It is home to hundreds of animal species, to include bears, wolves, bisons, elk, and antelope. We have some images of some of the animals. This is a geyser. So we're just looking through some of the images from Yellowstone. And there's our gray wolf and a bison. All right, and just so you know where Yellowstone Park is, it's up in the corner of Wyoming here. And remember, part of it is in Idaho. A little part of it's in Idaho. And a little part of it's up here in Montana. Kind of along there. All right, so I'm going to turn off my volume so that you can see this is about a 4.5-minute video.
Yellowstone is epic, strange, and iconic. It is well deserving of its protected status. But how did it come to be the world's first national park? Archaeologists have found evidence of human activity in Yellowstone that dates back at least 11,000 years. Oral histories of Salish Native Americans suggest their ancestors were here 3,000 years ago. Today, there are still 26 Native American tribes that are connected to this land. Some of the first European visitors included fur traders and trappers in the late 1700s. But the first big incentive for settlers came in 1863: gold. Prospectors flocked to Yellowstone in hopes of finding more. The Northern Pacific Railroad Company heard of the wonders of Yellowstone. A big attraction like this could help their plans to expand the railroad west. So they sponsored the Washburn-Langford-Doane Expedition of 1870. As the first formal expedition of Yellowstone, they explored vast regions of the park, including Tower Fall, Yellowstone Lake, and the Geyser Basins. Their most memorable achievement? Naming Old Faithful. Painter Thomas Moran, as well as a photographer and sketch artist, were also on the expedition team. Their work introduced Yellowstone to the world and captured the imagination of Congress. Then, on March 1st, 1872, President Ulysses S. Grant signed an act establishing Yellowstone National Park, the country's very first national park. The park is around 2 million acres, an expansive wilderness with places that even today few have seen. Filled with wildlife including 285 species of birds and over 65 species of mammals. But what's on top of this park is nothing compared to the giant reserve of magma that lies below. Thermal power is what makes Yellowstone tick. Old Faithful remains true to its name, and to this day gushes up thousands of gallons of hot water every hour or so. It's one of the most famous natural features in Yellowstone, but it's not the only one. There are over 10,000 thermal features in Yellowstone, including hot springs, mud pots, and steam vents. They sit in one giant caldera of a supervolcano, some 45 miles across at its widest. 2.1 million years ago, Yellowstone erupted and covered over 5,000 square miles with ash. About 6,000 times the volume of material ejected from Mount St. Helens in 1980. It's among the largest volcano eruptions known to man. Yellowstone is still active, and another eruption is possible, but it probably won't happen in the next 1,000 or even 10,000 years. In the meantime, Yellowstone hosts millions of guests every year. There are now 59 national parks in the United States, but Yellowstone will always be the world's first.
Okay. Sorry about that. Okay, so we watched that video and just learned a little bit briefly about Yellowstone. And then we started watching this following video. So notice it says complete the handout as you watch. I did not pass out the handout yet. That will happen next class. So we are not completing any handout, okay? But we're going to watch about 7 or 8 minutes of this video that is specifically talking about Yellowstone National Park. There used to be quite a lot of wolves, gray wolves there. They were eradicated. They were removed by cattle ranchers because the wolves were finding the cattle to be delicious snacks. And so the cattle ranchers did not want them on the land. But now we have reintroduced them. So this next video is going to kind of talk about how different people are reacting to having wolves back in Yellowstone Park. All right.
Here's something to soothe your tired eyes. Yellowstone National Park. We're here at a time when some members of Congress are talking about rewriting the Endangered Species Act to make it more friendly to businesses and landowners. Here at the park, one of the act's landmark successes was the reintroduction of the endangered gray wolf. But now those wolves are doing so well, they're moving out of the park and into neighboring valleys, where they seek the open space provided by cattle ranches. Now, wolves and cattle do not mix well. But what got our attention was how many cattle ranchers and environmentalists have found some common ground on this. William Campbell produced our report.
Bringing the endangered gray wolf back to Yellowstone National Park was a bold and controversial experiment, returning the stealthy predator to a region where they'd been completely exterminated 75 years ago has helped restore the natural balance of the world's first national park. But some wolves now roam outside the park's boundary, and that is a problem for the ranchers whose lands lie at the park's perimeter.
I don't understand where four-legged animals, wolves, mountain lions, have more rights than people.
As you can see, giving the wolves a second chance does not sit well with a lot of people around here. Remember, the reason the wolves were killed off to begin with was to help early ranchers settle the West. Doug Smith has been hearing a lot about that. He's with the Park Service and the leader of the Yellowstone Wolf Project.
The idea of bringing wolves back to many people was an insult.
So lots of pushback on this notion of what should we do about perhaps reintroducing them.
A lot of pushback. And I don't think this is an overstatement. Given the mythology of wolves, the stories of wolves, the culture of animosity that it goes back not hundreds but thousands of years, I would say that wolves are one of the most controversial wildlife species in the world.
Because that's one of the challenges here, is that the wolves can't read the sign as to where the park boundary is, and so they go out of the park boundary, and increasingly they're mixing with ranches and other populations who do not want them around.
That's true, and the reintroduction was designed to be boundaryless. We did not expect the wolves to pay attention to the boundary, and we told everybody that.
The 66 original wolves have multiplied to about 1,000, and just as the wolves are moving out of Yellowstone, more people are moving into the region. They're building houses and businesses on former ranch lands. Suddenly the ranchers, the wolves, and environmentalists all have something in common, a need for open space. This is quite a development. An animal the ranchers never wanted, forced on them by the Endangered Species Act, is helping create a coalition that might help both the ranchers and the wolves survive.
Okay, so the Yellowstone.
Wolf Project leader Doug Smith is busy each winter studying and tracking the growing population of wolves in Yellowstone Park.
You ready?
Armed with a tranquilizer gun and darts, he hunts from the air.
You see the black one here. Okay, there's 3 up ahead. See them in the opening up there? Okay. It's ahead, it's ahead, it's ahead.
Smith fits a few wolves in each pack with radio and satellite collars to track these beasts when they leave Yellowstone. The trick is to keep the sedation light.
We like them light, because then when we leave, they come out.
This spring alone, dozens of wolf pups were born in Yellowstone. The numbers are high enough that federal officials have proposed removing the Yellowstone wolf population from the endangered species list. But for the wolf reintroduction to be truly successful, biologists say these fast-moving animals need to expand hundreds of square miles throughout the entire northern Rockies. That translates into wolves roaming over a lot of ranches. And ranchers like Martin Davis really don't want the wolves back on their land. There are some people who look at these pictures and say, oh, look how cute, look how fuzzy, the wolf. What do you think when you think of these wolves around here?
Wolves and livestock don't mix. That's the reason they were eradicated back when. I look at them as a predator instead of something cute and fuzzy.
A fourth-generation rancher, Davis and his family have run a spread in Montana's Paradise Valley, just north of Yellowstone. It is tough work, and profits are hard to come by. The wolves don't help. They've attacked one of Davis's heifers and killed a calf. Other ranchers in the valley have also had losses. Although wolves account for only a fraction of the cattle that don't make it each year, wolves mean that ranchers must spend extra time and money checking on their herds, sometimes in the middle of the night.
We had some college kids that came by to ask questions about wolves and ranching. And one of the questions I asked them was if any of them owned any kind of a store. And the one girl says, yeah, my dad owns a hardware store. It was back on the East Coast somewhere. And I said, well, it would be just like your dad having to leave the back door open at night and saying, I hope the thieves don't steal too much tonight.
Since the wolves were reintroduced, more than 60 have been either captured and relocated or simply shot for killing livestock in southwest Montana.
Well, they killed one right out here. Oh, they did? About 400 or 500 yards over here.
So you lose an animal,
Yeah,
and it comes right off of the...
off the top, off your net profit.
Rancher Bruce Malcolm has lived and ranched in Paradise Valley all his life. He was on the Montana governor's task force that helped draw up a new wolf management plan that'll eventually remove special protections for wolves and treat them like any other wild animal.
Well, first of all, we had a predator that we did not want. We did everything we could to stop them from introducing the predators. But you know the story today. They're here. So now we're going to try and live with them. And we've tried to adapt and try to make management plans to survive.
Under the new rules, ranchers have more options to manage wolves. They can now shoot to kill, but only when the wolves are trying to kill their livestock. You ever just want to shoot them, Martin?
I know that other people say, well, if I would have seen him, I'd have shoot him. But that's not the answer either, I don't think. And especially when they are an endangered species.
That may not be what you were expecting to hear from a rancher. So what is going on here? It turns out that in recent years, a threat to the rancher's survival has appeared that in many ways is more frightening to ranchers than the wolf: real estate developers.
Okay, so we stopped there pretty much in all of the classes that have already met. And on our What's for Dinner Day 2, we're actually going to pick up and watch the rest of that and then have a handout that we can fill out. So that was pretty much our What's for Dinner Day 1. Please make sure that you've taken care of those 18 definitions and send in emails if you have questions. Thank you.